Hi, everyone. Thanks for joining our Hadoop Ingestion Made Easy webinar. My name is Ian Gomez, Audience Marketing Manager at DataTorrent. Joining us on the webinar is Dr. Sandeep Deshmukh, Committer with Apache Apex and Software Engineer at DataTorrent, and Mohit Jatwani, Product Manager at DataTorrent. Here are some logistics regarding the webinar. This webcast is being recorded. It will be available after the session has ended to watch again and share with your colleagues who are not able to attend our session today. Please submit your questions throughout the session. You can submit your questions via the Questions tab in your console, and we'll be happy to answer them as they come up or at the end of the session. Lastly, feel free to click the Attachments tab to view more relevant information regarding DataTorrent and our solution. Without further ado, I'll hand it over to Sandeep. Sandeep? Hi, Sandeep. Go ahead.
Hello. Yeah.
Hi, Sandeep. Go ahead.
Hi, all. Yeah. Can you hear me?
Yes. Go ahead.
Okay. Yeah. So today I'll be presenting on Hadoop ingestion made easy. I'm a committer at Apache Apex. So we'll be covering the big data ingestion definition, and then what are the challenges in ingesting data at scale. We'll be spend most of this webinar time for the demo of DT ingest, and then we'll summarize. Ingestion is the process of obtaining, importing, and processing data for later use or storage in a database. With the big data, it's just a bit modified to say that we have to discover the data sources, because now there are a lot many sources than they used to be. We have to import that data, process it into an intermediate data, and then send it to a durable data source. So typically we get it from some source and send it to some durable data source, and that's what we will be targeting for today's tip. Some of the challenges for ingestion at scale. If you are ingesting data at a very large scale, failure recovery becomes a very critical point. If you are ingesting and halfway through there is a data loss, not a data loss, if the system that is copying your data is failed, how do you make sure that you can recover from that intermediate state and don't restart from the beginning? So there are many such systems which can do that, which can copy the data, but they fail to recover from the intermediate states. The other big worry for people who like to copy data or ingest data is if you have big files and if you want to copy that one big file in parallel. So if there is a terabyte of file, how do you copy it so that you can ingest it maybe in half an hour or so, rather than serially reading it, which will take a few hours. Then if you have too many large files, then if you are creating, let's say, a process for copying each of the files, it's going to again take a very large time. Here the ingestion time for a particular file would be very small, but in general, the setup time to copy a file will be quite large. So we need this, both the cases in case of file copy to be handled seamlessly. The system should not perform very well in one case and very bad in the other case. Additionally, there are challenges of doing encryption, compression, and compaction of this data at that scale. Moreover, you would like to definitely have bandwidth limit so that you don't hog all the resources that are available with you. So we have a product, DT Ingest, which is free to download and use for all the people. We will come into how we can check up, download, and the rest of the things for it. For that product, the DT Ingest, we support file-based ingestion from HDFS, S3, FTP, and NFS. And for messaging queues, we support Kafka and JMS. So today we will demonstrate ingestion from HDFS to HDFS and Kafka to JMS. And we'll walk through how we can configure rest of them and use it. So far, any question, or we can move to the demo? So here, the DT Ingest is free to download and use. You can visit this link to download DT Ingest. The prerequisite for that is you need to have a Hadoop cluster with 2.2 onwards installed on it. And on that, you can simply install this binary. It's less than a minute's task to install it on a Hadoop cluster, and you can get started on that. Whatever I'm talking demo part, you can also offline go through the documentation. It has a very detailed tutorial how you can use it, and ample of screenshots where you can configure your DT Ingest utility to ingest data. Also, there were a couple of webinars prior to this, and these webinars cover the technical aspects of DT Ingest. How you copy data from the first case, how do you copy data, and what are the technical challenges, and how it is technically designed. So you will get all the technical details of this product. Similarly, also to ingest data from Kafka to HDFS. So those who are interested in understanding the technology behind, feel free to watch these videos. So we will move to the demo part. I hope everyone is able to see the console. Okay. So I have. So first, let's get into ingesting data from HDFS to HDFS. For the demo purpose, I have kept it on one of the HDFS clusters, but in reality, you can have a remote HDFS cluster on a different data center or anywhere in the world. You just need to have access to all the data nodes from where you will be running this utility. So after the installation, you will get a page which will look similar to this, and the DT Ingest utility, that is called the ingestion application, will be already installed with it. You will have to get into that particular utility page from the Develops tab here at the top left, and then you can launch this application. So this is the name of the application that will be used while you actually launch the application. This name has to be unique when you are running different instances of ingestion on one Hadoop cluster using DataTorrent Apex. So we'll keep this default as ingestion. There's an advanced option to specify queue, the Hadoop queue that you would like to use to run this application. Will not get into that part as of now. There's also another option where you can use the pre-configured or previously saved configuration to launch this. So we'll see how we can use it. So let's get started first with ingesting data from Hadoop to Hadoop. So here we have different options that you need to select for selecting the source. So here we will select HDFS, and then you'll get options to configure it. So the first parameter is what is the list of files or directories that you would like to copy data from. So I'll be putting it HDFS /node35.morado.com/user/dttbc/ ingestion/input. Okay, so from the backend we can see there is a directory called ingestion. Within that there is a directory called input, and we will be using this directory to copy the data. There are a couple of files right now, 1 GB file and 5 GB file. These two files we will copy to some other location. You can also specify the criteria here. In the filtering criteria, you can say that I want to just copy .dat files or something like that. And this is the way we need to specify the regular expression for that. For the input directories, you can specify more and more directories or even files. You need to give the absolute path of those files. You can specify them in here, and one can remove if not required. Then there is an execution mode where you would like to, where you can select whether you would like to execute this as a one-time copy. So basically, when you say copy and terminate, whatever files or data is present in the input directory, that is scanned once, and then it is the application will, after completion of the successful completion of the data copy, will terminate itself. The other option is continuous polling, where you would like this application to continuously poll for new files, and if there is a new file, copy it at the destination. So you can specify this polling interval in hours, minutes, or seconds. So for this demo purpose, let's keep it like 10 seconds. You can, in this case, also there is an option if the file is updated, or that file will also be considered as a new file because there will be a timestamp change, and that will be reloaded from source to destination. Next, let's get to setting the HDFS output. Here again, I will be putting some information. HDFS // node certified.morado.com/user/ingestion/output/hdfs, just to make sure whenever we copy data, we copy it to separate directories for verification. We have an option to whether we want to copy this data recursively from the source, or is it just only from the directory where it is copied from. So this is more to do with the way we'll copy data from the input source. So we'll continue to say yes. Option to select whether you would like to override the existing data. So if a file with the same name already exists, the destination side, should we ignore and do not override that file, or you should override that file? And then compact is another option where you would like to do a time-wise compaction. We will come to this option a bit detailed in later demo time. So we'll skip this and I'll explain these options later. Let's first get into launching this application. You have also an option to limit the bandwidth. So right now I'm saying limit the usage to 200 MB per second and not more. The last option here is to tell the application how many readers you want to ingest the data from the source. So it's basically giving you the option to control parallelism. Do you want to do it from 4 processes, 8 processes, 16 or so? So this number will be decided by the amount of data that you would like to ingest, as well as the latency that is allowed. So if you want to make sure that there is considerable data that is coming in on a regular interval and you want to get it to the destination as soon as possible, then it's better you keep this number a bit more. But if you are okay to get it at a slower rate, you can make it 2, 4 or something like that. For the time being, we'll keep it 4. Here is our configuration that we have done. We can save that configuration in a file. Internally, it is saved in the system so that next time, if you want to just use that, you can use it. So I'll just save it here. Bright talk and save. Actually, even if you just say launch with the name here, it will first save it and then launch it. So not necessary that you have to take this double step. We can directly launch it. So now the application is launched, and we can see here. It's getting launched in the cluster. So, sorry for the delay. I think it's a bit of network slowdown that's slowing down the loading of this page. Otherwise, it's quite immediate. Actually, the app is already downloaded at the back end. It's just that we are not able to see the refreshed page here. So meanwhile, if we have any questions, we can take them up.
So we have one question which is how we compare this to NiFi. We have one question which asks about comparison this of our application with NiFi.
So I'm not very sure about the NiFi thing. We do have a connector for NiFi in Apache Apex Mallar library, but personally I have not used it as such for any backup purpose. Any other questions?
No question is this sounds similar to DevCP. Can you discuss the use cases where our tool is better than either and vice versa?
Yeah. So let me just repeat the question. The question is, this looks very similar to DCP, and how it compares with DCP. So DCP, I'll just take that up. So there is, we could see it. I'll take that question later. So this is the console that you see from the DataTorrent RTS platform. Again, this is in the community version of DataTorrent RTS. You can use it for free. So you get this console when you install the DT-ingest utility. From there, you can see that the application is launched and running. There was a network latency, that's why we couldn't see this page earlier. But it already has started working, and you can see things are happening already. So let me just show you in the background very quickly how it is getting copied. What are the I would say steps that happen behind the scene. The more detailed description of this is given in the video that I just mentioned earlier about the technical details of file copy. So here, file splitter is an operator which reads, which scans the input directory, and it creates a smaller task for the downstream operators to actually copy the data. Block reader is the actual worker which connects to the source and reads data and gives it to the next operator, which is the block writer, which will write it onto the HDFS in a smaller blocks. So even if the file is 1 GB, we might be reading it in 128 MB in one go. Block synchronizer is the next operator which actually makes sure that all the smaller units or the blocks for a particular file are copied by the block writer. And once all of them are ready, then it tells the next operator that everything is ready for this file. I have this data spread across in these blocks. Go ahead and merge it. So this is a simple logic that happens behind the scene. And if you see here is the actual deployment, we had a specified number of parallel readers at 4, and hence we have block reader and writer combination of 4 here. These block reader and writer are connecting to each other. We call it as a thread locality, and there is no data. The data that is shared is very fast in this case. So again, this parallelism of 4 can be increased to 16, 32, 8, depending on your need of ingesting the data. So let's see. So the ingestion directory, and within that we had given the output as the directory that we want to copy the data destination. Within that, we have to specified HDFS, and you see within HDFS directory there is a directory called input. The reason we have the directory input over there and not the data from input directory directly is because if you have multiple directories as input, then it's better we segregate data into as per the input directory. So let's see what the input. Yes, so here are the files, 1 GB and 5 GB. And let me also show you what's there in the input. Let's make sure we have. Right? So we have copied a couple of files pretty much in the unbounded. Let me show you something. Okay, I'll do this. So now there is something that you can visualize this part, and that's also a very important aspect of using this application. So we'll go into the visualize part, and we'll create a new dashboard for visualizing what is happening here. So it has already detected that there is an ingestion application that is running, which we would like to use for visualization. Okay. So these are the couple of metrics that we can visualize. Let's use the first one, counter for this, and we'll select the pie chart, and we'll do add digit. Now this basically gives you a pie chart of what are the successfully copied files and which are in progress. Right now we tried to copy just 2 files and they're already copied, so it's just a complete circle. So we will demonstrate additionally how this will change. Apart from that, we can add a table of what's the status of files or remaining files, successful items, skipped items, and all these details along with the size. Let me add one more. This is a little more detailed description of what is happening. So it said these are the couple of files and all these are copied. The status is successful. Now let us move some. So I'll just show the index. Okay. So in the ingestion, there is directory with large number of small files. So let me move it into the input directory. So ingestion / input. Right. So we had, you can see suddenly there is a pie chart now. It is showing there are some remaining files. So we had a polling interval of 10 seconds. So within the 10 seconds, every 10 seconds there is a poll of what is going on. Right? So now it has scanned all the remaining files, and there are like a bunch of input files. That's why remaining files is 296, and copied files, which are the old ones, are just 2. And here you can see 569 files are remaining, successful are 2, and what is the data size that is already copied and what needs to be copied. So this is just a real-time view of now that it's getting copied. And it will keep changing as and when it gets copied. If you go to the, I'll just let me close this. Yeah, so you can see the files are getting copied. This is actually when it says getting copied, it's actually being regenerated at the destination side. So it was getting the files right away and storing in between, and now it is at the destination. And it's getting updated all the data. So this should be done pretty fast like this. I think this will continue. So let me now address the question of DCP. So, sorry, in DCP, the way it works is there is one map process that is fired for each file. So let's say there is a 1 TB file, one map will actually copy the entire file from source to destination. So the disadvantage for large files is you cannot read them parallelly. Or like 1 TB file, you have to just do it one. There is parallelism of one. Now, if you have hundreds of such files, like we copied now, it will spawn one map for each file. Even each of the file is like few KB, it will be one map, and that's quite costly because then you have to spawn a map, and that cost of spawning a process itself could be quite a lot. If you have thousands or too many files, it will slow down. Or on the other side, if you have just one big file, it's also going to be very serial. The advantage over here in this application is we have the parallel reading that is happening, and hence even our TB file can be copied quite fast. So let me just go through the other options that we have. So the other sources that we have is S3, where you can, I'll not be actually demonstrating this, but we'll just walk you through how to use them. So you need to specify this in the format of S3, and as a protocol we use / the user key and the user passphrase @ the bucket name and path of the directory of files that you want to do. As before, you can add more files, remove them, and all that can be done. Filtering can be done. Execution can be one-time or continuous polling. Output can be even now S3, NFS. So any of these input, any of the output can be chosen. Similarly, for FTP, It's ftp:// username password at host port and the path. So it's pretty much just that you simply specify the URL and rest of the things remain like it. For NFS or local file, there's no concept of needing a host name or a port or even the login credentials. So you just need to give the file path. But make sure this file is available. At least read access to this application, and if it's a cluster, this path should be accessible from all the nodes, because this is a distributed environment. So the operators that are copying can be deployed anywhere within the cluster. So if you are copying it from the NFS should be mounted on all the nodes in the cluster. Yeah. So on the output side, as we just saw, NFS, S3, FTP things remain as is. The compression on the file output side can be one of the option is gzip, or it could be, these are the couple of options we support right now. Then encryption could be symmetric or asymmetric. That can also be specified. Simply you put the key here and it should be done. Bandwidth usage we already seen from the input side we can do. Okay. So now let's move to the Kafka ingestion, where we have an ingestion from a messaging system. Here, the messages are coming one by one, and now we are going to put them into a directory in HDFS. So here, the topic name is test, and my user from. So I can specify a host colon, a port, multiple hosts and columns here, separated by semicolon. I'm right now just using one. It's node22model.com 12181. By default, it's generally 2181 port. Just adding one more here. And you can select whether you want to read data from earliest or from latest. I'm using latest here because this topic has about more than 100 million tuples as of now that I was testing for this demo. So let's not ingest that much right away. Let's try it on a smaller data set. The output could be here now any of the file systems. So first we'll, let's say, HDFS or NFS or something like that, or it can even be Kafka or Gem. So if you want to, let's say, read from one Kafka and ingest from one Kafka and put it onto another Kafka, or within the same Kafka but with different topics. So whatever is your business need, you can do that. And you just select Kafka and do that. Right now we'll do from Kafka to HDFS. And here I will just select it as ingestion, output, and Kafka. So all my records will be in this particular directory. I can again choose whether I want compression or encryption, which I'm saying is none. I really don't care about bandwidth as of now, but I can still specify bandwidth. I'll just say a demo and launch. Yeah, so this Kafka demo.xml is saved and the application is launched. here it is. We have the Kafka message reader, and then we have the file writer. So you can see message reader followed by the file writer. It's a very simple, straightforward application, but it's very powerful. It can read data from a single topic with many partitions at a very, very high speed. So let us try to push some data. So I have about 1.5 gig of file, some log for one of the applications that I was running, and I'll just push it to Kafka. And here it goes. You can see messages are being read and they are written onto the disk. So you can say roughly this is the speed at which it is processing per second, the tuples. Let's see what's there in the output. Yes. So these files are created at the output directory. Now, basically, when we are ingesting a lot of data, you typically like to save that data in smaller rollable files, because if you are ingesting 1 TB of data per day, you don't want that in one file, but maybe specify it as 8 GB per file. So it will automatically roll over after 8 GB to the next file, and that's why right now it's a 64 MB configuration. So there are many files, more than about 20 files, but that can be specified as an advanced property where you can specify, okay, I need a 1 GB file for this, and then you can do that. So we have actually ingested about 7.8 million records in a very short duration, less than a minute, I guess, right? And this is, if you see, just single reader and writer. If you can parallelize it, and that can scale to a very large data. At one of our customer site in production, they are ingesting of the order of, on an average, 28 GB of data per day, with a peak of about 35 GB. Okay, so the application is going on. So this is what basically I wanted to cover, and if you have any questions, you can take them up. So just to summarize and give you what optional processing that we can do, I'll just explain briefly. The compression, we support gzip and L0. Then we have the encryption, symmetric and asymmetric, and the compaction. So the compaction, I think I need to cover. I'll just cover it quickly. Yes. So here it is. If you have a data coming in from file sources, you can compact it. So basically, this is a size-based compaction. If you have, let's say, thousands and thousands of small files that are getting generated, and you'd like to back them up, and having those thousands of files, let's say per hour, could be very costly for the main node to handle. So typically, you'd like to put them into a single file, and then have a mechanism where you can retrieve those files if required. So compaction is that utility where you can specify what is the size that you would like to do. So I can very easily say I want a file of 1.8 GB for each, or let's say just 8 GB each, and I can specify the delimiter between the files as a new line. So it will create small files of 8 GB. So if you have a few KBs or MBs of file, all will be merged together into files of 8 GB, and it will roll over after 8 GB each. And there will be index file that can help you get into those particular files individually. So this is a size-based utility that you can do. This can be very much extended to a time-based utility where you can specify it as a time-based utility where you can have it hour-based, day-wise, hour-wise, minute-wise, or something like that. Okay. And yeah. So to summarize, it's quite easy to use. Just configure and run. And it's a unified for batch and continuous ingestion. In case of batch, you can do a one-time copy or you can do a continuous pulling. And it seamlessly handles large files as well as large number of small files. Yeah. So, Ian, if there are any questions, we can take them up.
Yes. Yes. Thanks, Sandeep. That was a great presentation and demo. We do have a few questions in the question console, and we'll get to most of them, it looks like. Okay, so the first question, Sandeep, is can you use DT-ingest backup and restore the Hive metadatabase? If so, can you provide details on the process to back up and restore the Hive metadatabase?
So, okay, let me just, so as I understand, the question is, can we use DT-ingest to back up and restore the Hive metadatabase, right?
Yes.
So
yes.
No, basically, anything that is file-based purely we can use, or a message-based can be used. So if this metadata for Hive is, let's say, accessible to us on HDFS directly, we can definitely do that.
Awesome. Okay. So the next
it's
question.
Actually on the roadmap to support this.
Great.
Yeah, go
okay,
ahead.
Sandeep. So the next question is, what are the security controls available with DT-ingest? And does it support rule-based access controls, RBAC? And what system-level users and groups does DT-ingest use between HDFS to HDFS clusters? Kind of a three-pronged question.
Okay. So, yeah. So from a security perspective, at a higher level, we have the DataTorrent RTS platform that supports role-based access. It can be used with LDAP or Kerberos. So DT-ingest is the utility on top of our RTS platform. So it inherits all the features that are available with the platform. Okay, so that point of view, security controls that are generally there available in the Hadoop security system can be used as is. Now, for the what system level users and groups does DT-ingest use between HDFS to HDFS cluster? There is no specific system level users that is needed here. Any user who can read the source and can write at the destination can be used. So for the demo purpose, I am using one of the users, which is a common user, but as long as you are able to read and write and launch this application, the configuration from the RTS platform side, if it is correctly configured, DT-ingest as such is straightforward to use. It won't get into any access control or user groups. But we can definitely restrict that from the platform using the platform feature.
Awesome. Thanks, Sandeep. We have another question. It says, if only one map copies the file, then how can parallelism be achieved?
Yeah. So let me just go back to the demo again.
The demo.
Just show it. Yeah. So I think I'll just show it. Luckily, it's still going on. So, yeah. So here you can see the block readers and block writers. So let me first clarify. The one map per file is DCP paradigm. Here, Apex has a different paradigm. Each of it's different from MapReduce. Apex is a streaming platform. So here, each of these smaller units are operators or small units of work that you can do independently, and they are going on continuously. So in this case, we run on top of Hadoop. We request resources to Yarn, and these are all operators or functions that are running 24/7. They are running right now. So there is no one map individually for a file. What happens is at the file splitter level, this operator will just connect to the source. It will scan for the data and it will tell to the next one, the block reader, that okay, this is the file, go and get read it. Or this is a big file, let's say 1 GB of file, one cannot read it. So it will say, first block reader, go and just read 1 to 128 MB. The second block reader will read 128 MB to 256 MB, that way. So if you just increase the number of parallelism for the block readers and writers, we can make it 32 or 16, anything, or 64, like for that matter. Those many parallelism can be done to read the data. So it's not a MapReduce thing, first of all. This is a paradigm, very simple. It's a streaming platform, and you can just specify how do you want to parallelize things. Yeah, thanks.
Great. So I have another question here for you, Sandeep. When do you use auto partition versus when to use static partition?
When do you use?
Oh, sorry. It says when do you use auto partition?
Yeah.
Versus
Right.
when to use partition.
Yeah. So basically, this fixed and auto partitioning, these are the couple of ways where you can use DT ingest for reading the data. The first one, when we say here we specified it as 4. There were 4 block readers which were reading the data from the source. And when you say auto, well, you don't need to specify and the system will take care of it. Now, when you say fixed, these 4 block readers will always be active 24/7. When you say auto, it can increase the number of parallelism to whatever is the required need of the ingestion data at that time, and it can scale down. So let's say I have a data, I have some data of 100 GB and I want to copy it. And it will automatically say that, okay, I have 100 GB of data, I need to ingest it fast. So it will, let's make it parallelism of 16. The user don't need to do anything. It will do a parallelism of 16. You can definitely specify what is the minimum and a maximum that it can use. So let's say here the minimum is 1 and the maximum is 16. So it will have a parallel reading of 16. Now, you have copied all the data. There is no new data at the input side. We would like to release those resources. Those 16 parallel readers are actually doing nothing. But we want to still be active and keep scanning. So what you can do is release these resources, make that 16 to 1. So that way we can release and just minimize the resource usage. Now, after some time, there are some more files, and you want to read them again. So the system will auto-detect that, okay, there is quite a lot of data that is coming in, I need to expand. So it will auto-expand to, let's say, 4 parallel reading this time. Read, once it is done, again, it will auto-scale down to 1. So that is how you can use the auto one. Now, when to use the auto one? Well, if you have data coming in burst and you want to do it quite fast, auto is one option. But if you want to say that, and the other part of auto is you can release the resources, and these resources can be used by other MapReduce jobs or other Apex programs in your Hadoop system. In case of fixed, you are requesting these many resources from the Hadoop cluster, and you are not releasing them anytime. So you will always be keeping that allocated. So these are the couple of scenarios where you can use them. Yeah.
Great, thanks, Sandeep. So we have a question just regarding our slides. Can we have a copy of our slides sent to our emails? Unfortunately, we can't do that, but I'll be happy to add them to the attachment tab as soon as we're finished. The next question is, earlier you said that only one map will be invoked for copying the file, then how the parallelism can be achieved? Does job going to wait until the complete copying done?
Yeah, so this one map is for the DistCP part and not for the DT ingest part. So the DT ingest utility will not be invoking one map. It will be actually doing a parallel read, reader and writer as per the specification, either in this fixed parallel readers count or the auto part. So it's quite dynamic, and it won't be one map. And also this DT ingest is not a map reduce paradigm. It's a lot more advanced in this of streaming data.
Cool. Okay, and so this is going to be our final question. DT ingest is free. Is everything else shown in the demo also free? If not, what is the cost? And how do you price out the software, assuming there is a cost?
Yeah, so DT ingest is free. The DataTorrent RTS platform that we have, there is a community edition that is available for free download, and you can use it. The console that I showed to monitor all these things is also available with that. But the support with that is community support. We also have an enterprise licensing platform where there will be an enterprise support, and even the enterprise, you can try it for a month for free. You can download and try it for free. And the widgets and the dashboarding part comes with the enterprise one. And for pricing, I would request you to get in touch with sales team on DataTorrent. I think it's sales@datatorrent.com.
Great. Okay, so that's going to conclude our webinar today. Thanks again to Sandeep for his awesome presentation and demo of DT ingest. Look out for more webinars by DataTorrent in the near future. For more information about DataTorrent, feel free to visit our website at DataTorrent.com. Thanks again for joining, everybody, and have a great day. Bye-bye.